Hello, all. This is Dr. Dave Maslach talking to you about reciprocity.com. The E is written with a 3. And in this particular video, I want to talk about alternative explanations in science. So if you don't know, I'm actually a professor of innovation strategy and entrepreneurship, and I created this whole reciprocity platform to give as much as I possibly can of myself. I was trying to figure out a way of how I can actually make me more scalable than I possibly can. So I created this sort of sharing economy proofreading platform component, and then I started actually doing these YouTube videos as a form of content marketing to get the word out there, because I think it's actually a really useful tool and very helpful for a lot of people. So with that, so alternative explanations. This is something that we often look for in science. This is a really big thing this is probably one of the biggest things that we do in science. That we, as scientists, what we try to do, and people do this too, we're kind of naturally sort of pre-exposed to do this. We look for correlations, or we look for things that happen within the environment. We look for A and B sort of correlating together, and we sort of say whether there is some sort of theoretical rationale or something that happens behind what's going to explain that particular relationship, right? So I want to give you an example of this, because this is what got me thinking about it. Gosh, it was a bad day for me today, if you don't know, for a lot of different reasons. But so right there, you can see that, right? So that right there is some of that is plum juice. And there is also spaghetti sauce on there. I had some spaghetti today, and I ate a plum, and I made a giant mess all over myself. That's why I'm wearing this shirt, not that shirt. I took it off. Anyways, so I started thinking, like, what the heck is going on here? And I automatically came up with two sort of competing theories, right? The two alternative explanations that can explain what's going on. The first one is, and this is the one that we sort of know, that's sort of, Murphy's Law, and that anything that is red or spaghetti sauce is automatically attracted to your t-shirt. The other explanation that I can come up with is that the fact that I'm wearing something that has high contrast with the sauce that I have, so that the explanation is I'm naturally kind of messy and dirty anyways, but because there's high contrast between the sauce that I'm having and as well as the t-shirt that I have, that is going to show up a little bit more than on the days that I don't have that sort of high contrast between the sauce and the shirt that I have. And so it appears as though that there is as sort of a bad, or it appears that on those days that I'm wearing a white t-shirt, that sauce is automatically attracted to that, right? So there's two competing alternative explanations, equally plausible. That, the one that there's some sort of force to white t-shirts that's pulling sauce towards white t-shirts, and then the other one is the high contrast argument. Now, what we have to do as scientists is we can rule out the explanations in a number of different ways. So the first way is we might do what is called, just digging deep into the literature and coming up with a theoretical explanation that might rule that out, right? So, maybe it's looking at sort of the rules of physics that we can say that, things just drop towards the ground, there's gravity, there's not necessarily a force that's pulling on white t-shirts, but we don't know that. There might be some sort of extra force there. Maybe it is, maybe it's a static electricity charge or something like that. So we can't necessarily rule it out. So we have to do some empirical tests. That's the second thing that we might do is come up with an empirical test to explore that particular alternative explanation. And then the third thing is we might, when we're running the test, we might control for the different conditions. We might sort of try to, we can naturally control for those particular conditions. There's my doggy. If you heard the shaking in the background, or we might, control for this empirically using mathematical equations and stuff like that. I won't get into that, but those are the ways that we might sort of rule out these different explanations. The theoretical explanation sort of gets to things to some degree. And sometimes people are okay with that, but we really need empirical data a lot of the times to sort of explain what's going on. And we can perform multiple sort of tests to explain what's going on. The first test that I was thinking about is we sort of drop spaghetti sauce towards the ground. We hold a t-shirt that's as close as we possibly can. We might go infinitesimally close to the spaghetti sauce. and then we tried to measure it, whether there was a bend in the spaghetti sauce and it's getting actually pulled towards the t-shirt, right? Like that. If I'm holding it like this, right, and then we drop the spaghetti sauce down, if there is some sort of special force on t-shirts, then it should theoretically pull that spaghetti sauce towards the t-shirt. And that would be a great test, right? So we can run that. We can run that with different kinds of spaghetti sauces. For example, we just sort of drip the spaghetti sauce down and see if it's actually going to make a difference. Then we can also run a second test, right? So we can get a bunch of people together. We might, maybe we get 100 people together. We want sort of a relatively large sample of people. And then what we will do is, have some sort of experiment where we have high contrast with our t-shirts, right? We have a high contrast and a low contrast sort of example. And one of them might be you're wearing, so we give half the people white t-shirts and the other people sort of gray t-shirts, right? So, and then, of those half, then we have sort of a control condition where we don't necessarily tell them what's really going on. And then another condition where we might say, or we might give them some spaghetti sauce. It's not like the best experiment to ever. And we get them to eat some spaghetti sauce and we see if they actually make a comment on, whether they actually spilt something on their t-shirt. And then we count the number of comments that they made on whether they spilt something on the t-shirt. And hopefully if there's a high contrast, if there's some sort of high contrast sort of example, that you're going to see more people actually recognizing that they're messy, right? And if that's the case, then we can probably say, so if test one, if we drop the spaghetti sauce down and we can't measure anything noticeably different with that spaghetti sauce being pulled towards the t-shirt, if it doesn't actually pull towards the t-shirt, and then we run a second test where we do the high contrast experiment, and we find that more people are sort of mentioning that they are messy when they have a high contrast, then we can suggest that there actually is, greater sort of likelihood that the high contrast explanation is sort of, is a more important thing, right? So, well, there's my dog again. So a couple of things with this, right? So we can't never in science can you actually ever rule out one particular explanation. That's just something like just by logic, we can never do that. And so there's always a chance that something could happen that could make that one particular thing likely, right? Some crazy thing that happens around the world, or all of a sudden, the earth sort of rotates the other direction and then makes that one sort of crazy thing true for whatever reason. But what we can do is try to rule out as much as we can in the favor of one possible explanation over another one, right? So we're always trying to rule out one possible explanation. It's called falsification. We're trying to rule it out as much as possible. So we have all these alternative explanations, and we say that, well, given these explanations and given these tests and given this data, the results of the data, it favors more this one possible explanation over the next one, right? And this is kind of there's a whole bunch of both statistical sort of insight on this, and as well as theoretical insight, and as well in psychology too. That's becoming big about that Bayesian sort of views, and it's reusing what is called Bayes' view. I believe he was a priest from like the 1700s, 1600s, a long, long time ago. And he just had this idea that we have priors in how we see the world, and then we have some sort of, we bring information to the world, which informs our priors, and when you sort of combine that effect, then we have what's a posterior. And that the posterior, the thing that we come up with, is a little bit more informed based on this data than what we have before. And that is the sort of general logic of that. And that's how we sort of move. We incrementally move and build knowledge as we're sort of updating, and we are making those priors a little bit different every time. And we're giving a little bit more weight to one particular prior than another one, or we're coming up with different sort of explanations on how the world actually is going to work based on what we know, right? And here's the thing that's kind of interesting, I think, And this is what the sort of psychology research is pointing towards, is that we as human beings, this is how we sort of understand the world, right? So it means that this is how physicians will understand the world. This is how engineers sort of understand the world. So physicians, in the case, this is how they're making a diagnosis. They sort of do an experiment, quote unquote experiment, not necessarily a real true experiment, but they just kind of are poking around, seeing what's going on. They run a test. They see if they can update their view of how this patient is actually sort of behaving, or what is going on with this particular patient. And then once they run that test, they can look back and say, you know what, we can rule out this thing. I'm not 100% sure that we can rule it out, but I'm 95% sure that we can rule out that thing. Actually, 95% is like kind of a magical cutoff that we use in science a lot. That gets us in trouble. There's a whole bunch of stuff on that, but I'm not going to get into that. But, we're looking for a sort of good enough evidence that we can rule out the other explanation, right? So you can go into the doctor and, you have two sort of explanations. One of them might be you have cancer, and the other one is that you just have some sort of weird genetic thing that's going on with your body. And you run all the different cancer tests, right? I'm not a physician in any sort of means, but that would, if you get sort of negative results, then you can sort of rule out that cancer test. But that doesn't mean if you ran it again, you're not going to sort of find that cancer is there, right? It just means that in that one particular instance, that the cancer test came back negatively, and so it gives you more results, or it gives you more sort of understanding that it's probably some weird genetic thing that's happening to you at this moment, right? And so this is how engineers sort of make sense of the world. This is how CEOs would make sense of the world. This is kind of a basic understanding of how we are understanding that people actually make decisions, right? Is that or one way that we understand how people make decisions is that they're just constantly updating and coming up with better explanations and ruling out alternative explanations as we go. And that's what we as scientists have to do, is rule out those explanations. And there's crazy ones, right? And that's totally fine. Having a crazy sort of explanation, a crazy sort of thing, alternative explanation is actually good, because sometimes those crazy ones are better than the ones that we currently have, right? Because they explain more of the world, and we wouldn't have necessarily sort of explored those unless somebody actually proposed something that was really crazy and off the wall. So that's all I wanted to point out, is what we're trying to do with science, and we're trying to rule out these alternative explanations as much as we possibly can to come up with better explanations that are a little bit more, maybe they explain the world a little bit more generally, for example, or maybe they just explain the world a little bit more a little bit more in a fine-grained way, that we can explain more of what's going on using what we know, right? And usually what we're looking for is what's called parsimonious or simple explanations, as much as we possibly can. And sometimes it's, the simplest explanation is the best one, but sometimes these simplest explanations, we have multiple simple explanations. We try to rule out the ones using sort of a battery of tests to come up with one that actually makes sense with what's going on. So that's all I wanted to talk about. Hopefully you found this interesting. Give me a thumbs up and do subscribe to the YouTube channel. I do appreciate it. All right. Take care and have a wonderful day. Bye.